Thank you. So hello all. So I hope you guys are all well and having a great week. So tonight, Middlesex University Product Design Engineering, and Design Engineering are really excited to host our 14th talk in the annual guest lecture series. So this series runs weekly throughout the academic year on Thursday evenings, bringing together a vibrant mix of speakers from across the full spectrum of design and engineering. So we have a mix of leading practitioners, opinion leaders, radical thinkers, and emerging talents to inspire and support professional development for all of our participants. Tonight, we're really excited to host Emel Cankaya, aerodynamicist at McLaren Racing. So, as per the details that were circulated via email, Emel graduated with a BSc and an MSc in Aerospace Engineering. She specialized in aerodynamics from the Technical University of Delft in Netherlands. And then she also completed her MSc thesis at MIT, at Massachusetts Institute of Technology in Boston, USA, in the AeroAstro department. In 2019, Emel joined McLaren Racing as an aerodynamicist. She's been working on enhancing the performance of race cars by designing aerodynamically efficient parts. And the goal is obviously to make the fastest car on track and to win races. As usual, guys, feel free to gather your thoughts, your questions, your comments in the chat throughout the talk. We're going to have Q&A at the end as well. And there's also the option to go live and interact after the main talk. And without any further ado, over to Emel Cankaya with a talk titled F1 Engineering.
Thank you very much. I also have a slide where I introduce myself, so it will be a bit dull, but that's fine. So yeah, today we will be talking about engineering and Formula One. I will first give a short introduction about myself, about who I am, what I studied, my career path up till now. And then I have a short video about McLaren Racing itself, so you guys can see what McLaren Racing is, when it was founded. Then we will talk about engineering in F1, so some roles in Formula One. And then after that, specifically about what I do at McLaren Racing as an aerodynamicist. And at the end, there will be some room for questions. So first, I will tell you guys who I am. As explained before, my name is Emel. I was born and raised in the Netherlands. When I was 7 years old, I saw a documentary about space travel, about astronauts. And that day I decided to become an astronaut, actually. And that's why I decided to study aerospace engineering in the Netherlands. And I was lucky enough, there was a good university in the Netherlands where I could do this. So I did my undergrad, so bachelor's there. And once I graduated, I started with my master's there. In the Netherlands, it's common that everyone does a master's and nobody really stops after their bachelor's degree. So I completed my master's degree in aerospace engineering and then specifically in aerodynamics in Delft. In between, I also did my master's thesis at MIT, which was a little bit longer than a year. During my studies, I got interested in Formula One, so this was not really a childhood dream for me. And after I got interested, I started looking for jobs in Formula One, but it was kind of difficult to get a job there. So I applied, I think, at least 5 times. But then I didn't get in, so I needed a backup plan. And strange enough, I started with a career in banking. I started with a traineeship, which is some sort of a graduate program at ING in the Netherlands. I also worked in their New York office in the USA. After 2 years, I decided to try Formula One again. I thought maybe this time I get lucky to get in. And this time, indeed, I got hired by McLaren Racing as an aerodynamicist. And since then, since 2019, I've been working there. Now I will show you guys a short video about McLaren Racing. Do you guys see this Zoom screen on the right or not?
Yeah.
To the left now.
Yeah.
Okay. And let me know whether you can hear the sound because can you hear it?
Yeah, perfect.
Let's start at the beginning. I'm a racing driver. I always was, always will be. Ever since my dad restored an aging Austin 7 Ulster and I entered my first hill climb competition, I never stopped. age 22, I won my first Grand Prix and became the youngest ever winner up to that time. I would push the car to its limits over and over and over, on the track, in the paddock, in the mechanic's shop. I'd modify it, improve it, and master it till I dropped on the floor with exhaustion. In 1963, I founded my own motor racing team. Now, let me tell you just one story so you get what it was about. One day, as I was testing a car, I noticed that the fuel filler access door was flapping up and down. The thinking at the time was that it should have been pressed more firmly in place as the speed of the car increased, but instead it bounced more vigorously. At first, I was angry that the door hadn't been properly closed. I've always hated sloppy work, but an idea was soon born out of my frustration. Stopping in the pits, I jumped from the car, ran to a mechanic's toolbox, grabbed a pair of shears, and started cutting the bodywork away behind the radiator. You should have seen the faces of the mechanics. Immediately, I began turning lap times faster than before. From that incident came the nostrils, a key design feature that is still used today. On the 2nd of June, 1970, my Can-Am car crashed on the Levant Street just before Woodcote Corner at Goodwood Circuit in England. I was testing my new M8D when the rear bodywork came adrift at speed. I died, age 32. But what might be seen as a tragic end was in fact a beginning. As I always said, to do something well is so worthwhile that to die trying to do it better cannot be foolhardy. Indeed, life is not measured in years alone, but in achievement. That'd make a good epitaph, wouldn't it? So, on that beautiful summer day, on that racetrack, I did more than leave a name and a memory. Hopefully, I became an inspiration.
Well, he indeed became an inspiration for me because, as you guys could see, he was not only a driver, but he was also an engineer, a mechanic. He was doing everything. He was involved in every step, let's say. And so from McLaren Racing is one of the oldest active teams in Formula One. So it has one of the richest history. It was founded in 1963 by Bruce McLaren, who you also saw in the video. Its first race, McLaren's first race was in 1966, and in 1968, they won their first Grand Prix in Belgium. And up till now, we have 183 victories and 12 world championships. So now next is, I will give you guys some introduction into engineering in F1. But first, I will tell you a little bit about Formula One itself. I'm sure everyone already knows. But Formula One is basically like a big circus. That's how I explain it. Because we're traveling with the entire team and all the tools, the car, all the tools, to different tracks in different countries to compete in races. This year, there will be 23 races and 10 teams. So it's pretty niche industry, sport. And the goal of every Formula One team is to design and manufacture a car that wins races, basically. So the fastest car on track. I've also listed some of the engineering roles here on the right. I'm saying some of because this is really not everything. There's so much more. We have different kind of roles. Let's start with race engineering. A race engineer is the person you can hear who talks to the drivers basically during race weekends. And that person acts as a link between the driver and the team, because the team does a lot of analysis. There's so much going on behind the scenes, and they give all this information to the race engineer, and then he informs the driver. And he's also, of course, responsible for making sure that the car and program are managed properly. Then we have performance engineers, and as the name says, they look after the performance of the car. They do lots of data analysis. We have a lot of telemetry analysis going on, and that is basically graphs, analyzing graphs of speed, force, etc., etc. And they collect all this data and try to give the best advice to the driver on how to go faster. Then we have controls engineers. There's so many controls on the cars, both cars. We have, of course, 2 cars. And those controls engineers, they look after the reliability of the car. It should be reliable, those controls. And they want us to deliver the maximum performance, get the maximum performance out of the car. Then we have engine engineers. So this is split into performance and systems engine engineers. Performance engineers look after the performance of the power unit, the engine, and the systems engineers look after the reliability of the engine. Then we have race strategists or strategy engineers. Those guys and girls, they come up with the strategy of what we want to do during the race, and think about the number of pit stops, what tires we use, like track positions, race scenarios, and of course our goal is to win races, to be on the front of the race. Then we have aerodynamicists like myself, and we are responsible for designing a fast car, basically. And I will get into this a bit more into detail later. And then we have simulator engineers. So we have sims at our factory, like every other team. And here we learn a lot about the track itself, about like weather conditions, how that affects our driving, about specific strategies, like the strategy guys can test some strategies in the simulator as well. But also the drivers themselves can practice their driving there. And the simulator engineers, they are responsible for preparing, developing and running this simulator. And also they are responsible for the data analysis. They gather all the data and make summary and communicate this to the rest of the engineers who might be interested in that. Then I have a short introduction of McLaren Racing, about the factory and the offices, because it's both in the same building. And I will tell you, this has no sound because I will tell you like what you see as well during the video. So this is McLaren Technology Center. And as I explained, it's based in Woking. Here you see the boulevard where we have old and new cars. And this is actually for partners or visitors who want to see what McLaren is, just so, show them our cars from the past, but also now we have also new cars there, and all the trophies are there as well. Then on the top floor, where they are now, this is specifically the racing bay. On the left-hand side, if you go to the left, there's automotive, but we are 2 separate companies, so we don't do anything with automotive at all. Here you have racing, and they are going into the offices now, which they won't show. But what you see here is, for example, mission control. And this is where during a race weekend, the engineers and also the engineers I just explained before, like strategists, engine engineers, like everyone works from here during race weekends and analyze data. And they feed this back to the race engineer, who then can communicate this towards the driver. So there's so much work going on here during a race weekend, and it's yeah, you need to do it immediately. It's everyone is under pressure because you cannot just postpone it till later. You need to do it now. And here you can see, we can see the race, but out of experience, I can tell you that you don't really follow the race when you're working because you're so focused on your own job to do it right, that you don't really have time to follow what's going on the race. You only follow your own team, basically. Then, yeah, they're working here. And then if we go a little bit further, yes, here, this is a room where we, if they go in a bit further, you can also see where they are. This is for guests, basically, or yeah, we can sometimes bring family and friends as well. Here is the room I just showed you before, where the engineers are working. And from here, our guests can hear what we are hearing. They can hear us talking, but they can also follow the race on this screen here. So it's pretty cool for them. So it's like they're also working for McLaren. Nice experience. Then if we go further, yeah, here you see them again. Next is, I'll go a bit further. Yeah, this is the simulator, what I talked about before. And here, this is telemetry, like all the, lots of graphs, lots of data, and those sim engineers, simulator engineers, they follow the data, they do a lot of data analysis. So yeah, this is like really a separate job as well. Then if we go further, this is our wind tunnel at McLaren Technology Center. They don't show the test section because that's confidential. But this is actually the old wind tunnel. Currently, we are renovating it. We are making it bigger. The reason for that is that in the past, we could test 40% model cars. And later that changed to 60%. So you can test a bigger car, which is better. But our wind tunnel was too small. So currently we are testing in Germany. I go to Germany quite often for a wind tunnel test. But we are also renovating it. So hopefully next year, somewhere next year, we will go back to our own wind tunnel. And later on, I will explain you what a wind tunnel is and what we do there. Yeah, that's the tour, I believe, yes. And then we're back at the boulevard as well. Okay, so now a little bit more about what I do specifically as an aerodynamicist. Aerodynamics is one of the key differentiating factors to stay ahead of the competition in Formula One. And I am specifically involved in the aerodynamic development of the race cars, and with the main focus on making the cars go fast, so adding performance to the race car. And what we are trying to do is we are trying to maximize downforce. I will show that here on the right-hand side and explain later what those terms are. But we are trying to maximize downforce and cut down drag. So basically, we don't want any drag, but that's not possible in real life. So you're trying to minimize that. In the next slide, I will explain you what those terms are. I'm not sure whether you guys are familiar with it. I will put this here on the right-hand side. So downforce is what you also can see on the picture on the top right here, is a force that pushes the car on track, which then allows us to go faster. We generate this force by using the airflow around the car. So basically this flow that flows from the front to the rear, we use this flow to generate downforce. Then we have the drag force, which you see here at the bottom. That is a force that acts opposite to the motion of the car. And that's why it also slows down the car. And you can see it as, for example, racing with a parachute, which is not efficient as you guys might imagine. We always try to design the car specific to the track, not specific to every track, but we usually group them. We look at, okay, which tracks have a lot of straights and which tracks have a lot of corners. Because if you have track with a lot of straights, you don't worry so much about downforce because you can just go fast on straight. You don't really need grip or downforce to stay on the road. But we worry more about drag. You don't want drag because that slows you down. But if you have a lot of corners, you need more downforce to stay attached to the road. And so you can go through the corners. So then we worry more about downforce and not so much about drag, because you cannot go super fast anyway in a corner, not as fast as on the straights. That is about those terms. And then I also wanted to show you a little bit about what else we are trying to do. So it's not only about downforce and drag, of course, it's mainly about that, but also parts have also other duties, let's say. For example, okay, I will explain it first before I start the video. So Formula One works best in clean flow. So when the flow is clean, not disturbed, if that's, in front of the car, that's when the Formula One works best, because that's when you generate downforce. But if you have dirty air, before I continue, does everyone know what dirty air is, clean air is? Or do I need to elaborate a bit more on that?
I don't think they know what dirty air is.
They do.
Zoe says, elaborate, please.
Turbulence and stuff. Anyway, so dirty air is in the air you have particles, and if you have the clean air, let's say, then those particles travel smoothly, so the flow path is smoothly. If you have dirty air, which you can actually see here, it's all, it's not, there's no pattern in it. It does whatever it wants. You cannot really predict it. So you need dirty air to generate downforce. However, some parts on the car make this clean air dirty, as the one what you see here. One of those parts is, for example, the tires. You cannot do anything about this because you are not allowed to change the tire. So what you do is try to look, this dirty air, as you can see, goes to the, in top view, you can see it better actually. Here, stop. So this dirty air goes into, for example, the rear wing and under the floor. And when it does that, it spoils the clean air there. And then that means that those parts where there's dirty air, they don't work anymore. Like they don't work as well as when they're in clean air. So that means that you don't generate enough downforce. They don't really do what they're designed for, the parts. Therefore, what you are trying to do is you are trying to move this dirty air away from like the car itself, so the rear wing, but also the floor. And how do we do that? With certain parts on the car, you do that. For example, one of those is the front wing. As you can see, you're generating vortices and they push this dirty air away. You see, it's going out. And that's good for the car because there's clean air coming in now. And that's basically how we are trying to make the car work. And it's not only the front wing that does that, there's multiple other parts on the car that try to clean up the air as well, let's say. So the front wing, of course, is responsible for a lot of downforce. It generates a lot of downforce, but it also cleans up the air that goes towards the rear of the car. Let me see whether there's anything else. Yeah, that's it from here. Okay, so I explained to you guys what's like the most important terms in Formula One are, like downforce, drag, and clean air, let's say. And now I will explain you a little bit more about how we design the car, like what is the design process in aerodynamics specifically. So we start at a drawing board, basically. So we have a special software where we can design parts. And before I continue with this, I will also explain you that I specifically work on the rear of the car. Everyone has his or her own area because it's kind of, you need to understand that area a bit before you can really do work on it. So I work on the rear of the floor. and I design parts there. And we design it first in we have software for that. It's called computer aided design, and you design it there. Once you've designed that, oh yeah, it's also this exclamation mark here is very important because we cannot design whatever we want. There are technical regulations within Formula One, and they are set by the FIA. So they decide on where you can design what. And as engineers, we try to be creative and work around those rules to still design devices that generate downforce at minimum drag. Once we have designed the part, we first test it in our virtual simulation environment. And we test it here because what we want to know is how much downforce this part generates and how much drag and how that affects the lap time. Like lap time is how fast you go on track. Then if the data from here, if the results from this virtual simulation tool look interesting, then we send the part to the wind tunnel. So we then make the part and then send it to the wind tunnel. And I explained before that currently we are testing 60% models in the wind tunnel. We cannot test like an entire car because that's not allowed. In the wind tunnel, again, we are trying to replicate the aerodynamic environment the actual race car experiences on track. We actually do the same. Sorry? Oh, I thought someone said something. So yeah, we also try to replicate the actual environment, the race car experiences on track with our virtual simulation tools. So with both, we do that. So after we've tested the part in the wind tunnel, and again, here we measure the forces, downforce, drag, also other forces, and the effect of this part on the lap time, how fast we go with, how fast it makes us. I have to say that, again, the number of virtual simulations we can do and wind tunnel tests we can do, it's governed by the FIA. So they decide how many of those tests you can do. You cannot do an unlimited amount of tests. This is also regulated. So you need to be careful with what you test and when you test that. Once we have tested it in the wind tunnel and we have verified the results of the virtual simulation tool, and they both look interesting, we send the part to track. So we test it on the actual race car. And again, here, if it looks interesting, we measure like forces and how fast this makes us. And once we are happy with the results, we basically can leave the part on the model and test it during the actual race. So, and this design cycle can be very fast. And with fast, it can be within like 1.5 to 2 weeks, for example. So yeah, design cycles in Formula One are very fast if you really need to do it that fast. And usually we want to make the car faster. So whenever we find something that's interesting, we try to get it on the car ASAP. If a part doesn't look interesting, or sometimes even though it looks interesting, we go again back to the drawing board and try to see, in case it was not interesting, why was it not interesting? Why didn't it behave the way you were expecting it to behave? Sometimes that can happen, and you need to analyze that with a lot of data from the virtual simulation to tests, but also the tests on track, because sometimes you miss things during the actual races, and then you see that later on. We analyze that, and from there we again continue with the design, testing, etc., etc., etc. So it's a continuous loop, basically. Let me see. Yeah, that's everything what I wanted to tell here. And that's it, really. I just wanted to leave some questions for you guys without boring you too much with a lot of information. Are there any questions?
Amazing, amazing. Thanks, Emel. It was a really great talk in terms of overview of you, your journey, McLaren, insights into F1 engineering. Guys, if you want to continue to gather your thoughts, your questions and comments in the chat, feel free to do that. If you want to go live and interact, please also post a request in the chat as well, and we'll definitely make it happen. There's quite a few questions coming through in the chat, so let's go through them. So the first one there, guys, from Yusuf, he said, what do you think about the new McLaren, the MCL 36?
Well, I think it looks pretty good. And during the race weekend, so even though during winter testing, you don't really can compare different cars to each other, because the main reason for winter testing is to collect a lot of data to see whether the car is reliable, to see whether it's stable, does it always react the same in certain conditions. That's basically what we are trying to figure out now. But I think in general, it looks pretty good. But as I said, we cannot really compare it to other teams yet. That will be during the actual test sessions in March, hopefully.
Amazing. And another question, I guess, what's your opinion on the F1 World Championship season, the ending in Abu Dhabi? What was your opinion on that?
Oh, you mean the race between Max and
Hamilton? Yeah. Mm-hmm.
I personally think, I was really disappointed for Lewis, because he was almost there and he was pretty fast as well. But yeah, in the end, unfortunately, things didn't go as he wanted. It was a bit unfair, I think, but yeah.
It is what it is.
Yeah, exactly.
Talk with us. You'd like to go live? Feel free to unmute yourself. Talk with us.
Yes. Hello. Lovely to meet you. I have a question about the new car reveals, especially Red Bull. They revealed the fake car in media release, and now in winter testing we see the real aerodynamics of it. And there are some very interesting things new it did on side pods, and that possibly double diffuser. What do you how do you track what the competition does in the beginning of the season or during the season? Do you still use the secret photos and visual 3D drawings?
I cannot really tell too much about this. But yeah, of course, I'm interested in what other teams are testing. So of course, I check other teams and see whether we have missed maybe something during our development. Usually we have tried already a lot of things ourselves, and not everything we see on other cars work on our car, for example. But yeah, there's only a limited amount of what I can tell about this topic, unfortunately.
Of course. And a question from Kai Stopford. Kai's asking, are there any consequences in terms of losing races for the design and engineering teams?
Usually it has a lot of consequences for the heads, like the senior people, because if, for example, you keep losing races, then usually they leave the team and someone else replaces in the hope that they, improve the team. Of course, another very important consequence is the motivation within the team, of course. If you keep losing, then you get a bit demotivated. Also for us, for example, we had very good races, but we also had some bad races back to back. And then you're a little bit demotivated. You think, okay, I worked so hard on this, it's not working. Why? But it's really a team sport. So it's not down to one department, but to how you work together as well. So yeah, it demotivates you, but then you need to try to motivate yourself again with your colleagues, because otherwise you can never win races.
Amazing. And I guess that leads on quite nicely to the next question from Charles Mortimer. Charles is asking, which member or members of the team have the most pressure put on them typically?
Everyone really, but I think mainly the seniors, because they get from the shareholders, basically the owners of the team who put money in it. They ask them, okay, look, we're not winning. Why not? We're spending so much money. What's going on? Where's the money going to, for example? So I think mainly the top people, but then we also feel it if something is not going well, because everyone wants to make the car fast. And if it's not going fast, you also feel that. So, yeah.
Amazing. Another question, and I guess this relates a little to the last couple of years. So how did COVID-19 and the restrictions affect the design and manufacture, the protocols and the working methods? Like, did things change or have to change over that period? Yeah, so we started working from home. Before COVID, nobody would have ever imagined that you could, as a Formula One team, work efficiently from home. So that changed because I worked, for example, quite long, like almost 2 years from home. I think as McLaren Racing, we were one of the teams that
work from home for the longest period, because I heard that other teams had to go back to the office earlier. But what I found out is actually that when I work from home, I am way more efficient. I get much more work done than when I'm in the office. But the good thing about the office is when you work from home, I don't do that. I don't really call someone up very fast. Hey, what do you think about this? But when you sit next to each other in the office, you do that. So I think that dynamic, you don't really have that when you work from home. But on the other hand, you get more work done. So I think you need to find a balance in that.
Amazing. And a question coming in from Anonymous. Anonymous is asking, have you felt a necessity to make any changes to the car with the pre-season tests, or are the computer tests accurate enough?
I cannot tell too much about this, I think, because this goes a bit into detail.
Of course.
Yeah.
Maybe like I guess another question related to that, perhaps. I'm like, what's the level of iterations and the speed between the iterations and the development and the addition of parts? Like if you give like a time scale, time frame, like the changes that are made, how quick they're made and tested, and the process of, you know, the thoughts and towards the implementation of these parts on the actual car.
First of all, all of this depends also a bit about on, like, for example, this year we have the financial budget cap. So you cannot just send everything to the track, whatever you want to test. So you need to be a bit more careful, a bit more smart about what package you want to send. So instead of sending everything, you send packages. You find performance on the car in different areas, you make a package, you send it to the track to test it there. But for example, from the moment you test a design, like a part in the virtual simulation tool. So let's say from the moment you design it to testing it in the wind tunnel, it can be very fast, it can be a week. And when you're happy, and like some other teams did the same, like the front, mid, rear, you can make a package the next week, for example, and send it to track. So it can be super fast. And the number of iterations, I don't know, you test, I think, like 5 designs per day per person, for example. And if everyone in a team does that, that's quite a lot. So you do quite a lot of iterations per day. And that's like almost 7 days a week, I would say.
Wow, amazing. And in terms of the wind tunnel, obviously you mentioned that there's obviously FIA regulations there in terms of how many times you test in the wind tunnel. A question for yourselves would be like, what's the process of taking a part to the tunnel in terms of staying within the FIA regulations? Like, how do the FIA know how many times you test and conduct those tests internally?
Oh, we have cameras, so they can see that. You have to record every run you do in the wind tunnel.
Wow.
There's a gap. They ask, why is there a gap? They want everything. So you record everything, so they know how many tests you did and how long they test those tests for, because it's in number of hours rather than just number of tests.
Amazing.
Yeah.
Super interesting. And
yeah.
A question coming through from Tariq Imad. Tariq's asking, what happens during the very few seconds in the pit stop in F1 race? So what, like, he wants to know, like, what goes on in a pit stop?
Well, in the pit stop, what happens is our goal is to change the tires as fast as possible, of course. That goes on, but sometimes it can go wrong. Sometimes, I don't know, the wheel nut doesn't want to come out or whatever. And then there's stress. So yeah, our goal is to change the tires as fast as possible so we can get going again. And they practice a lot for that.
Amazing. And James Buhan's asking, like, how do you fit so much technology into an F1 car whilst keeping it light and aerodynamic?
Yeah, that's a big challenge indeed. You have to think about the materials you use, how many electronics you want to put in the car, how many sensors you want to put on the car, how heavy the driver is, everything basically. Yeah, it's not easy, and you have to, if for example the car itself is heavy, then we as aerodynamics team need to think about, okay, how can we make that part lighter? So what kind of material can we use? Or can we remove something that makes the car lighter, like a part, for example, without losing too much performance?
Mm-hmm. An interesting question for you, Emel. For example, I think one of the facts in terms of F1 racing is obviously the driver loses weight during a race as well. So how
Yeah.
does that have an impact on the aerodynamics?
Well, the lighter the car, the faster the car, of course.
Mhm. Mhm.
So yeah, it influences the speed of the car. If you lose weight, let's say, then you go faster.
Mhm. And Anonymous was asking like another question based around this as well in terms of the development of a car. Do you develop it from scratch, for the new season, or what's the process in terms of developing a car from for the new season?
Well, it was from scratch completely because it's a completely new car. We started from zero, and we did that in like within 1 year-ish. So it's pretty impressive, actually, if you think about it.
Mm-hmm.
Because if last year, for example, or the year before, you started from a car that already existed and you changed certain areas on the car. Of course, you try to make it faster. There are some technical regulation changes, but this year it was so big that you had to design a complete new car.
Amazing. And a question from Yusuf. Yusuf's asking like, what's it like working for a big F1 team like McLaren?
I love it. I mean, it was my dream. During uni, I was like, oh, I really want to do this. So it was really my dream. I tried a couple of times, it didn't work. And then in the end, it worked. After 2-3 years, I managed to get into Formula One. What it is like is it's very high pressure, I must say. So you have to do everything quite quick. But that's what I like. And what I really like about Formula One is that the turnaround time. So from the moment you design something to the moment you put it on the car is super fast. So for example, if you compare it with designing a space shuttle, that takes forever when you compare it to designing a race car. So that's what I really like. Fast design cycles, high pressure. Everyone in the team is motivated because otherwise you cannot really survive, I think, in Formula One. So yeah, the team dynamic, that's what I really like.
Amazing. And touching again on this year's car, Jonathan Ogilvy asking, how many design considerations did you have to make for this year's car when comparing it to the design of last year's car? And how challenging was this when standing out from other teams?
So that's a difficult question because we didn't see the car of other teams. It's of course all confidential. So you don't really know until the moment you really test it on track, basically. We had no idea how other teams were. We don't even have an idea how fast we were, let's say, because you never test on track. You only have virtual simulation tool data and also wind tunnel data, but that's it. So it's a bit difficult in the beginning, but of course you can compare the level of downforce and how fast it is to last year's car. Of course we did that. But comparing to other teams was not really possible.
Mm-hmm. Amazing. And Charles Mortimer is asking like, what are the main areas and parts of the car that you look at to increase the downforce?
When I first started, I worked on the at the rear of the car where the rear tires are on the inboard of that. So the rear brake duct, you have winglets. I worked on that for 2 years. As I said, at first specialized. And after that, I moved to the floor. So for 2 years, I designed winglets on that little area there.
Amazing.
What I like about the wind tunnel, I run quite often the wind tunnel. And especially during COVID, I did that because, as I said, I was born and raised in the Netherlands. And there and traveling to Germany was easier for me than people traveling from here. And also due to the COVID restrictions, it was just easier for me to go. But in the wind tunnel, you learn actually way more as well because you test everything, not just your own area, but also other areas because you are running the tunnel. And that's where you learn quite a lot as well. So basically, I learned a lot about the front, the mid there as well, and not really by designing it because I never designed it myself.
Amazing. And another question coming in from Anonymous regarding the suspension choices. So has aerodynamics influenced the suspension choices for the MCL 36? So like he was talking about the variety and the diversity of suspension between the teams this year. And he says he guesses each team had a different reason for each choice. So like what's the reason for the suspension choices on the MCL 36?
So it has a mechanical reasons as well as aerodynamic. We try to adapt to it as well. So for example, you have a certain, like mechanical wise, you decide on using some sort of suspension, and then you try to make that as aerodynamic as possible by designing, designing it in a very aerodynamic way. So it's not just aero, it's also mechanical. Yeah.
Amazing. And Torvidas is asking the question in terms of advice for getting a job or a career in F1. Like, what's your advice for getting a job in F1? And in terms of the team, do you have like product designers, industrial designers in the team as well?
We have designers, yes, but they are CAD designers, let's say. So computer-aided design, that software I was talking about. They are specialized in that, and that's what they do. How to get a job in Formula One? I think it's very important to have some experience. It doesn't really have to be in a company, but for example, we have Formula student teams. You can do that because that really demonstrates that you're interested and that you have some experience, because usually teams are looking for experience. Like a relevant degree, of course. What I usually see in Formula One, I mean, in my team or the people I know, is mechanical engineering, for example, electronics engineering, aerodynamics, like aerospace engineering. Those are really the main studies people get a degree from. Mm-hmm. But of course, if you can show with another degree that you can apply that to making the car faster or to whatever role you are applying to, I'm sure you will have a chance. For example, I worked in banking for 2 years after my graduation from uni. And after that, I got a job in Formula One too. So it's really about demonstrating that you can apply what you've learned at university to a real-time problem. And of course, it's really important to be motivated to show why you want the job.
Definitely. And in terms of, talking about CAD and simulation tools, what CAD software do you guys use, and what simulation tools would you suggest, both us to learn, Torvidas is asking, alongside what you guys use for your virtual simulations?
Yeah, I cannot tell that, unfortunately.
Amazing. And then another question from Yusuf. Yusuf's asking, how long does it normally take you to design the parts?
It depends. I mean, if you want to test a certain part, it can be 5 minutes, it can be an hour. It really depends on the area and what you're changing. Mm-hmm. Today I did 4 designs, for example. But sometimes you change something small and sometimes you change something bigger, which needs more time, of course.
Of course, definitely. And I guess this leads on quite nicely to the next question from Jonathan. So obviously you touched on, working in the rear of the car at the moment as well. Have you ever had any opportunity in terms of designing specific parts such as the DRS system as well?
No, I never worked on the rear wing. No, I didn't do that.
Mm-hmm. A question coming in from Ron Robinson. Do you design the McLaren cars in a way that the air coming off it would have a greater effect on the opponent's car, maybe?
So the rule change, the FIA changed the rules for this year, as you guys know, and the main reason was to allow cars to follow each other closely and overtake each other more often than we saw last year, for example, and that's to make the race more interesting. And for that, yes, as I explained before, cars cannot really generate downforce in dirty air. Last year, the cars were leaving behind quite a lot of dirty air. It was like kind of exploded and kind of like a big region. This year, the FIA tried to move that dirty air up so it doesn't really affect the car behind the car it's following. So yes, that was the goal of the FIA, and they achieved that. Amazing.
And a question coming in from Manu. So I guess there's quite a few questions touching on software and simulation. So ignoring obviously what McLaren uses in particular, looking at applicants coming in, those who are working at McLaren now from a mechanical engineering background, electronics engineering, etc. Perhaps maybe what software did you have practice on, at both at academic level, undergraduate, masters, and for example, prior to going into McLaren, that students could perhaps be acquainted with perhaps?
At university, we learned in Delft that they taught us Cankaya, like V5. Mm-hmm. So that's what I learned in uni. Like CFD wise, ANSYS, for example, is what I use quite a lot. yeah, those were really the main things I use in uni, also for my thesis, doing my thesis.
Amazing, amazing. And then Ramsey Hyde is asking, does each tournament have different rules, such as like what tires are allowed to be used, other equipments, etc.? Are there different rules for different tournaments?
No, no different rules for different tournaments, to be honest. Yeah.
Amazing. And Yusuf's asking another one, like, so is there any specific company that you would like to work for in the F1, or are you happy with McLaren?
Of course, I'm happy with McLaren.
And then, for example, Ramsey Hyder is talking about the constraints and the FIA regulations. Does it make it hard for you to be creative with the designs, or do you have flexibility there as well?
Yeah, it was pretty hard, to be honest. Especially this year, it was completely new as well, and then you had to think in a different way as well. So it was pretty difficult. And I must say that we have developed the car quite well, actually. So we have a car that we built. So now it actually gets more difficult. I mean, that's how I, experience it, because you've tried already so many things, and then it gets more difficult to be more, like, even more creative. You think, okay, what else can I test within the regulations? There's so many things you want to test, but you cannot because of the regulations. Mm-hmm. So yeah, it gets quite difficult.
Amazing. And Jonathan's asking, like, when does the development on a new car begin? Is it towards the end of the season, or is it at a much earlier stage?
It really depends on how the season goes. Yeah, if it goes super well, you can move early on maybe, or some teams that already maybe have moved, I don't know. But it depends on how the season goes.
Amazing. Talking about other teams, Anonymous asking, what do you think about the Haas team, the front wing end plates? So he's saying they're very different from any other front end plate that he's seen in the other cars as well.
Yeah. How shall I explain it without... I usually don't really talk about the aero other cars as well, because then I get too much maybe into our design. I don't really want to accidentally give away information.
Of course, of course. Mm-hmm. So a question coming in from Ramsey Hyder. Is it true that if you work for a brand, you aren't allowed to use other brands? So like to speak, it's a funny question. So you have to drive a McLaren to work?
Oh, I don't have a McLaren. They don't give us McLarens. I wish it was true, but
yeah, I think that's
what I thought as well before I started. But then I got disappointed.
Amazing. What's it called? And Man is asking, can engineers in F1 work without having a nomadic lifestyle, like rather than only living in one city, not traveling that much and so forth?
It depends a bit on your role. For example, if you are like track based, so if you go to track for your job, then you travel quite a lot. Like, that's really demanding. But I am factory based, for example, but then I have to travel to Germany all the time because our wind tunnel was there. So that was also really difficult. You don't really have too many weekends, let's say, because you travel all the time. And then if you stay there longer, you spend your weekends there. Mm-hmm. But then if other people are mainly factory based, so they don't travel at all for their job. But then it really depends on where you are in the season, because it can be super busy and then you have to work also in the weekends. Or sometimes once you've designed the car and you think, okay, we're happy with this, you can slow down a little bit, take some breath and just continue again. So it really depends on where you are, what stage you are, and what your role is.
Amazing. And Talk With Us is asking, like, in terms of your time in F1 so far, what's the biggest lessons that you've learned in F1?
Biggest lessons I've learned in F1 is teamwork is really important. Communication, not like that specifically, teamwork and communication, because you can work on a part, for example, but if nobody knows about that part, they cannot adapt their designs to your design. So communication is key. You need to try to find a healthy life balance between your work and your private life, because if you work too much, you cannot be as sharp and innovative as when you get some rest. And Formula, I learned that Formula One is really high pressure. Everyone was saying that, but when you work there and experience it, you really say, okay, yeah, true. It's very high pressure. Yeah, and you need to try to motivate yourself. As I said, that's really important, being able to find self-motivation.
Amazing. And also cool, a question coming in from Yusuf, going back to the pit stop. If someone makes a mistake, like they take too long to put the new tires on, do they get sacked?
I don't know, actually, because I never asked what happened to a person who screwed it up, for example. I don't think I don't know, actually. I don't think they would immediately fire them. I mean, everyone deserves a second chance, but I don't know, honestly.
Amazing. And a question coming in from Tortvilas, I guess related to material selection, material science. So what's your process in terms of choosing materials? So he's working on a telescoping extendable longboard for his final project, and he needs to make some decisions soon. So he's asking for some of your advice. So
what you consider is how heavy that material is, of course. Whether it depends on for what you want to use it. Is it heat resistant? What do you want to do with that part? If you use it in a very hot environment, for example, the brakes in a Formula One car, you need some material that can resist that high temperature. Or do you want to use it for very low temperatures? What do you want to do? So it really depends a bit on what characteristics you are looking for.
Amazing.
But we have a materials team that also looks after this. We work with them.
Amazing. And the last couple of questions. So Olusei Abdul's asking, why do a lot of the chassis of F1 cars look relatively similar? Is it the most aerodynamic design which fits within the regulations?
Why it looks similar? I don't think they all look super similar, but yeah, I mean, there's some regulations indeed, and everyone's trying to, fit their design in that. And it's just not only about regulations, but also how it works with the rest of the car. Other people, it really depends on how you design, for example, the floor where it comes together, and yeah, it really depends on the whole package. But yeah, the regulations are a very important factor, because usually you try to make use of the entire, space you have.
Mm-hmm.
But sometimes that's not efficient because, I don't know, it doesn't really work with the other parts you have.
Definitely. And Anonymous was asking, in terms of literature or any reading, are there any books or any literature that you can recommend? He's read one by Adrian Newey. Yeah, that's
a good one indeed. And there's another one, I cannot come up with the name. That's what I used in uni. I can send it to you when I find it. I don't remember now, but that's what I used in uni. That was really useful. I had only one race car aerodynamics course in university. But we used a specific book for that. It was something Cuts, I think it was.
Mm-hmm.
K-A-T-Z, I think. I'll look it up and send it to you.
Amazing.
But yeah, the one of Adrian Newey is really good as well. Yeah.
Amazing. And the final question coming in from Professor Mehmet. What are the career progression opportunities in the F1 sector?
There's so much. So in Formula One, we have, oh, you mean what my career perspectives are, or what other?
In general. In general, somebody starts with I don't know, on the material side or on the design side, or on the testing side, and how do they progress? Are there progression opportunities?
Yeah, but it's a bit more difficult.
Yourself,
Yeah, it's a bit more difficult.
And where are you going? And
so it's a bit more difficult than other companies. I compare it to the bank because I used to work for a bank. There's much easier to make career because it's a much bigger company. Formula One teams are small. There's not a lot of people who work there. So it's basically like a triangle. You start here, you work towards the top, but it's really difficult because it's very small, the team. And people move teams a lot. If they cannot get what they want in the team they work for, they move to another team if they see a position there, what they fancy. So career progression is a bit difficult in Formula One. For example, in Aero, what I could become, what I would want to become, is, for example, head of Aero. But yeah, it's very small. I need so much experience to get there. I only started 3 years ago. And people in Formula One have been working there since, I don't know, super long. And it's difficult.
Thank you.
Amazing. So Emel, a fantastic talk and a great Q&A session as well. So thank you for your time, for the talk, for the Q&A as well. Participants, details of the talk and Emel will sent to your emails ahead of the talk, including links to the LinkedIn, the McLaren website, and the YouTube link, which has a nice bite-sized lesson in aerodynamics as well. So definitely feel free to browse and connect. And to conclude, thank you, Emel, for taking out your time and joining us tonight. It was a great, informative overview of you, your journey, McLaren, and insights into F1 engineering.
Well, thank you for listening and for the great questions. I really like it when people are super interested. So thank you. And yeah, maybe we become colleagues one day. Who knows?
Amazing. And thanks to all of the participants and attendees who've joined tonight as well. So all students, staff, alumni, participants, we really look forward to seeing you all again next week. So keep an eye out on your emails for the details of the next speaker and links to the talk as well. Until next week, until next time, stay well, stay safe, and thank you guys.
Thanks again, Emel.
Bye-bye.
Bye-bye.